California's specialty crop production systems are unique in the world, but there are many management interventions that have to be made to ensure the sustainability of these production systems. Today, we will discuss the weed management component of these systems. Competition from weeds in specialty crop vegetable production can cause severe yield losses. Weeds not only cause direct yield losses, but can also harbor other pests and disease-causing agents. Therefore, weed management is an important component of vegetable production systems. According to Dr. Steve Fenimore of University of California, Davis, and Dr. Douglas Duhan of Ohio State University, weed management programs for specialty crops are more expensive and less efficient than other major crops because of higher labor inputs. Many specialty crops depend on hand weeding because of the lack of registered herbicides. The cost of hand weeding is also increasing because of labor shortages. Typically, herbicides were introduced to specialty crops almost 40 years ago, and there have been no new herbicide modes of action introduced in recent years. Therefore, there's a great need to integrate other methods of weed management in specialty crop vegetable production systems. The tools for weed management include mechanical, cultural, biological, and chemical methods. Mechanical methods can include cultivators. Cultural methods could include cover crops and crop rotations. Biological methods could include the use of insects and animals. Chemical methods are primarily herbicides and fumigants. There are several challenges and opportunities in weed management in vegetable production systems. Today we are going to meet Dr. Steve Fenimore, Extension Specialist with the University of California, Davis, to discuss some of these issues.
I primarily work in specialty crops between Watsonville and Oxnard, and that consists of vegetables, mainly lettuce and broccoli and spinach and celery, some carrots and strawberries throughout that whole range. Weed control ranges, the crop I know that has the highest weeding cost, or the weed control cost, is strawberries. And that's because strawberries are in the ground for about 14 months. Strawberries, this is the current cost and return studies indicates that strawberries has about a $1,600 per acre weeding cost. In crops like lettuce, you have a very complex integrated weed control system, and that's a good thing. Because in the context of the national weed science issues, such as herbicide-resistant weeds in soybeans in southeastern U.S., they have reduced the weed control system to a very simplified system. Here in vegetables, you have very little agricultural chemical support in terms of herbicides. The herbicides we have are very, very old. And so you have a much more complex system. But the interesting thing is the cost, and I just looked at the Iowa State University numbers for field corn the other day, and even with Roundup Ready field corn, the cost, the fraction of the gross crop value that's spent on weed control is about 3%. If you go to the University of California lettuce cost and return studies, the cost of weed control, which is, while it's much larger in lettuce than it is in field corn, it's about the same percentage. It's about 3.5%, 4%, somewhere in there. So weed control is important. The difference between field corn, to use that analogy, is field corn, if you have weed competition, you can still get a harvestable crop. You just get less of it due to the competition. In lettuce, if you have weed competition, you get distortion in the quality of the produce, and you have 100% yield loss, because if it's too costly to weed the field, the growers simply disc the field under and start over. They pass that. So the difference is, we're dealing with produce here in broccoli and spinach. that's viewed by, it's human food, and it needs to be cosmetically attractive. Otherwise, it's worthless. It's not even animal feed, it's simply composted.
The cost of weed control can vary.
Because of the value of the crops, it's actually not terribly high for the most part. The ones that I've looked up, 3 to 5%, somewhere in that range. In strawberry is a crop that I work in a lot with plant pathologists, and the pathogens that you have, that the growers contend with in strawberries, like verticillium and macrophamina, are both lethal to strawberries. Just kill it, they don't get any yield at all. Whereas weeds are a secondary pest. Weeds are an expenditure. It would be, I've never heard of a case in the 21 years I've been here of somebody completely losing a strawberry crop due to weeds. I have heard of that in vegetables. It simply, in lettuce, if things get out of hand, as I said before, they simply disc the field up. And because it's a 60 or 70 day crop, and it's easier to start over and do better. So it's actually a fraction, but it is a real cost, and it uses real labor, and that's another issue.
Another factor to be aware of are the weed species.
Well, one of them that's very frequent in this field is burning nettle, shepherd's purse. Those are fairly common. Common purslane is very, very common here. The shepherd's purse and the burning nettle are problems throughout the Salinas Valley, and that's because they're very fast. They go from seed to seed. We have measured this in a year-round basis in burning nettle. It can produce seed in about 40 days or less. It can go from seed to seed in 40 days. It won't produce a lot of seed in 40 days. If you give it 60 or 80 days, it'll produce a lot more. But purslane is becoming more of a problem for other reasons. The issue about purslane is that uprooting it doesn't kill it. You uproot purslane by two different ways, with a cultivator or with a hoe. And we actually did that work a long time ago when I first came here. We uprooted purslane at weekly intervals, like 1 week, 2 week, 3 week, 4 week, 5 week, 6 week. And purslane, you can only kill it if it's less than 4 weeks old, after 4 weeks from time of emergence. If you go past 4 weeks, the plant becomes large enough to survive. And what's more, if a cultivator or a hoe hand chops it in half, you take one plant and you turn it into 2 plants or more plants. In other words, you can transplant it. So purslane is becoming much more difficult. Some people spend the money on hauling it out of the field, and that, when labor was cheaper, which it is not cheap now, but when labor was cheaper 30 or 40 years ago, it was fairly common that people would carry a bag, and as they're pulling the weed hands, as they're pulling purslane, they would put it in a bag and carry it to the end, and they burned it or buried it or somehow disposed of it, but they took it out of the field so it didn't set seed. But it's all about seed management, seed bank management. The advantages of the cropping system in this area is an incredibly diverse rotation. Lettuce is planted, for example, from about December 21st is when the plow down date ends. We have a lettuce-free period from the 7th to the 21st of December. By county ordinance in Monterey County, where we are, there can be no lettuce in the soil. That is to break the cycle of the lettuce mosaic virus. On the 22nd of December, start planting, and generally in the South Valley. And they continue planting until Labor Day, which is in early September. So it's a very, very long season. So what you do, for example, right now we're standing by some beds that have been pre-irrigated, and then we've gotten about 3 or 4 inches of rain on them just recently. Today is the 26th of March, we've had a miracle March. So we have pre-irrigated beds. Pre-irrigation is a management system for the seed banks, and in my research, we've gotten as much as 50% weed control out of that technique. Basically what you do is you prepare a finished bed, you irrigate the field to stimulate weeds to germinate, and then you can use an herbicide spray like Roundup, you can use a Lilliston cultivator, you can use a propane flamer, you can use anything that will kill small emerged weeds. They're going to be less than an inch tall. So they're fairly easy to control, literally with any of these. This is a very important technique in organic and in conventional. So that's one thing. What that technique does is it reduces the seed bank in the upper layer of soil. So that's a start. We're just getting started on weed management in the Salinas Valley. So there's crop rotation, there's stale seed bed, that's the technical term for it. Okay, then we plant the crop. Let's plant lettuce. The lettuce, in a conventional field, we're going to use an herbicide like curb. I'm going to band it over the row. And so the crop comes up, the weeds come up in it. We've got a depleted seed bank because we used a stale seed bed. We pre-irrigated. We've got an herbicide band over the row that's about 5 inches wide, and we're going to have some weeds there, but many less. So the first thing we're going to do after that is we're going to cultivate the field, and we're going to get about 80 to 85% of the weeds that way. And then we'll progressively get as close as we can to the seed line, but we don't want to damage the crop. And then we'll either use a machine thinner, an automated lettuce thinner, using machine vision to space out the lettuce into, say, if we want to romaine, maybe a 9-inch spacing. And then we're going to run a hand weed crew through the field, and we're going to remove the remaining weeds. We're going to cultivate. So we've got an integrated system. You've got multi-layer, you've got redundancy, because remember, there's a very important thing. You only have to kill one weed one time. We did an analysis using a number of my trials, and the weed control system in lettuce, about 45% of the weed control was provided by the curb herbicide, while the rest of it was basically cultural practices, and it was hard to separate them out, and cultivation and hand weeding. So you have a very complex system, and it's very robust, and we don't have herbicide-resistant weeds because we're not dependent on herbicides, and we're not placing selection on them to any extent. And the weeds are constantly being buffeted by the changes in conditions and the multifaceted methods of weed control. It is a wonderful model for how to do a weed management program. It works. Let's focus on success and quit focusing on failure.
There are several important components of integrated weed management.
In this system, the mechanical weed control portion is very dependable and very effective. I've done it hundreds of times with mechanical weeders, whether we're using the conventional intra-row weeders, inter-row weeders, or intra-row weeders. I'll define that in a minute. We get very good weed control with cultivation. It's always been used here, and I predict it always will. It's not terribly expensive. That's one aspect. Obviously, the herbicide is important. We have an herbicide, curb, in lettuce. We have another herbicide in broccoli. That's Dacthal, and we have goaltender. In spinach, we have Ronit, which all of those products, with the exception of goaltender, which is the newest of the group, registered in the early 1980s, as I recall. All the rest of them from the 60s and 70s. They're fairly old products. Curb, for example, in lettuce provides about 50% weed control. On the other hand, we're very dependent upon hand weeding, which is very effective but very expensive. The last cost and return study in lettuce shows about $160 to send a crew through the average Salinas Valley lettuce field.
While chemicals can be used for weed management, there are some difficulties that can arise.
Well, the most frequent problem is that the grower puts down a chemical and then he changes his mind, or he needs to change the crop. Like, no, we don't, the buyer of that grower's lettuce says, well, we've got too much right now in that planting slot. We would rather you grow spinach. And you can't just switch. So if you put the herbicide down prior to planting the crop, you're sort of committing yourself. And so the question comes up, I'd say probably several times every year, it's about time for those questions to start coming in, is, hey, I've got this field treated with this herbicide, but I can't grow this crop because the buyer doesn't want it, they want something else. Am I gonna get in trouble? And we usually go, well, you really can't do that. You're sort of stuck. Maybe you need to look at the label and plant something else that's on the label. You can't really say anything else because anything else is illegal. So that's a frequent problem. Carryover, most of the potential for carryover from herbicide from one crop to the next. People here are very savvy about that. That's maybe an occasional problem where you put an herbicide like pendimethalin down or Treflan, and then you plant spinach behind it, and the spinach is very, very sensitive. Spinach is sensitive to everything. So you need really clean ground, no herbicide residues. Because of the system here, carryover is a big issue.
In recent years, there are several new and innovative technologies being introduced in specialty crop production systems.
Is robotics. It's simply because our technology has rapidly improved and our ability to create intelligent cultivators has dramatically increased.
Another new tool that can aid in weed management is the automated lettuce thinner. Although the machine is designed for thinning lettuce, it can also help eliminate weeds. These cultivators have cameras mounted on them and can remove weeds from even within the crop rows.
Basically a camera that's linked to a computer that turns a spray nozzle off and on. The spray nozzle is either spraying an herbicide like carfentrazone or a caustic material like, say, phosphoric acid or ammonium nitrate fertilizer. Lettuce is fairly easy to kill with any of those.
Here is a lettuce thinner in action. This process is also helpful in controlling weeds. As you can see in this picture, some of the weeds in crop rows have been sprayed with a chemical by the automated lettuce thinner, and the weeds will be eliminated.
So the next step, the next innovation to talk about is cultivation, intelligent cultivators. And there's two commercial machines. They are on the market. This is not science fiction. There is Robovator, and I can point right over there. Pacific Ag Rentals actually has commercialized it. That machine is from Denmark. The other one is Stickety from the Netherlands, and that also is that's with Sutton Ag here in Salinas. Those are commercial weeders. They actually reach into the row. They're intra-row. They reach into the row with cultivator knives that remove the weeds. They are, in essence, a weeding robot.
This is a robotic cultivator.
The thinners and the current weeders, they recognize a row pattern. They do not differentiate between the crop and the weed. They cannot tell the difference. They can tell the difference between the lettuce plant and the soil. They cannot detect the difference between a lettuce plant and a shepherd's spurs. They just simply see them, that's a plant and that's a plant. So the next step, and the one that that's being led by engineering professor Dave Slaughter and a number of other people in the engineering department, and Richard Smith is part of that project, and Mark Siemens with the University of Arizona, another engineer on that project. It is to find a way to differentiate so that the machine knows this is a lettuce plant or this is a tomato plant. And I see these other plants out there, but they're not tomato plants, so they're not lettuce plants, and therefore I do some type of actuation. The actual act of killing the weed, either by a sprayer or with a knife, a cultivator knife, or with some other action, is called actuation. So there's detection. From an engineering perspective, the terminology is detection and actuation. So with a human hoe hand, is something that's very familiar. Our eyes and our brain are the detection system. The actuation is the movement of the hoe to chop the weed out. So we're trying to move that, allow that weed hand to go make more money harvesting lettuce, or some other, driving a tractor or do something else more productive and make more money and maybe get more time sleeping at home rather than working such long hours for low pay.
Keeping up with technology is key for new students entering the agriculture industry.
Technology is a very fast-flowing thing. There's a really good book I would recommend you read. It's by Tom Friedman. It's called Thank You for Being Late. And Tom Friedman talks about the speed of change of technology. And he's not talking about agriculture, he's talking about everything. And he describes the technology as a river. Now, you or I cannot stop a river. A river is going to just keep moving. We cannot. We can deal with the river, we can get a boat, we can get in the river, we can stand and watch the river. We can partake of what the river is doing. We can contribute to its flow if we build a canal connecting with the river. But we can't stop the river. You guys are going to have to deal with this for the next 30 or 40 or 50 years. You need to keep up with the technology, because I just heard of statistics. The students now graduating are going to be doing jobs 20 and 30 years from now that have not been imagined today. And so the process of education does not end when you walk out the door after graduation. It's going to be going for the rest of your life. I know I'm 62 years old. I have not stopped learning. And you know what? It's a lot of fun.